Hello class. Today we're going to learn how to construct equilateral triangles. Before we get to that, let's go over some basic vocab. So if we have 2 points, let's call them A and B, and connect them. What do we have if we put that all together? Here's a picture of it. That is a segment. And if we have a segment that goes from the center of a circle, like we have down here, to a point on it, so this green segment here, that is a radius. And here is a pretty technical definition. So if we have a point and a radius, what do we get if we look at all of the points that are the same distance away from that radius? That's a circle. That's not usually the definition that pops in your head when you think of a circle, but that is the math definition of it. Note that the circle is just the circumference part, not the inside of it, just the outer edge. So, what are we going to use circles for? Well, we can use them to solve some problems throughout geometry. So, Margie has some cats, and let's see, she has Simon. Simon is over here on her bed, and Jojo is over here on her chair, and she thinks that her third cat, Mac, will be equidistant from her other 2 cats. So they're all going to have the same distance away from them. So however far Jojo is away from Simon, that's going to be the same as Jojo to Mac, or Simon to Mac. So where must he be? Maybe somewhere in the room. Well, we're talking about equidistance, and if we look back at our definition of a circle, that's kind of embedded in there. Now, the part where all the points are the same distance r away from a point C. So they're all equidistant. So when we're looking for those equidistant cats, we're going to draw circles. So you should draw some of your notes. Doesn't have to be perfect. Just best you can. You might not have a compass at home. That's okay. We're going to practice that skill more in class. But just do the best you can to make it look accurate so you can understand your notes and study from them. If you want to fix stuff in class, if you don't have a compass at home, that's fine too. So, first thing we're going to do, we know that Mac is somewhere that's the same distance that we have here from J to S. So the first thing we're going to do is let's connect J and S. That's our distance. Try to get as close to the center of the points as you can. There we go. So, now, so we have the pointy end on Jojo and the pencil on Simon. So we're going to draw a circle. That circle is going to be centered at Jojo. So Mac must be somewhere on the circle. That's a lot of points. What else do we know? Well, we know that Mac must be the same distance from Simon. So it's very important that you don't change how large your compass is right here. If you change the size of your compass, you're not going to have you're not going to preserve the equidistance that we're looking for. And so now we draw a second circle, and there we go. Now when we're doing constructions, we put everything in our construction that we drew, or the construction parts of it at least, we dash them. So we're looking for where do those dashed circles meet. They meet at 2 points. We got one down here and one up here. Well, only one of them's in the picture, so only one of them makes sense. So she thinks that Mac must be on the bookcase. So there he is. Let's label that with an M. And let's connect those points. And when you connect them, what do we end up with? We have an equilateral triangle. Exactly what we were looking for. So what's important now is that you understand the process and that you can explain it. It's very important that you can explain the steps in a way such that someone who's not familiar with the problem could repeat what you wrote down and solve the problem. If it's confusing, if they can't really get it just right, you might want to go back and change your wording or make it more precise. So precision is very important here. Now, I want us to think about the steps and how we would write them down. And we're going to look at how Euclid actually wrote this down in the Elements, ancient Greek book. So think about the steps we did here for a moment. You might want to jot them down. And then we'll look at what Euclid did. So here's Euclid's proof. This is very math speak. If you can understand this, that's really awesome. This is like college level proof here. Let me zoom in on that for you. So this is how he broke down this proof. And it's really wordy. And if you're not familiar with the terminology, it's really confusing. So what I did is I broke it down for you. And you can compare what I wrote in, like say, plain English, and compare it to what you have for your proof. So basically the beginning of it is just saying you start with a distance, JS. Right? Here we have A, B, and the problem we had Jojo and Simon, so JS. Distance between the cats. And then what did we do? We drew two circles with that same radius at each center. That's essentially what it says in this proof through here, just more precise and technical. And then what did we do? We drew a triangle. We picked one of the points where they crossed as our third point. And then we knew that all three of those lengths are the same because they're all radii of those circles. We made sure the circles have the same radii. Therefore, since they're all the same, our triangle is equilateral. So like I said, don't freak out about Euclid's proof. It's very technical. What's important is that you understand the process and you can understand what I wrote over here in the right-hand column. If you like to, you can compare the two and see if you can match them up. But Euclid's proof isn't what we're looking for right now. So let's talk about some vocabulary now. Construction, there's two basic constructions that we use for everything else. We can connect 2 points with a ruler, straight edge, or we can draw a circle. Now, it's important to note, sorry about that, that when we're doing constructions, we're almost never using the ruler to measure things. When we're measuring, we're almost always using the compass. Reason for this being there weren't standardized units of measure really back with the ancient Greeks. I mean, they had them, they had units of measure, but they weren't really standard throughout all of Greece or the world. So you had to be able to do these in a way that generalized. So no matter what type of measurements people were using, they could still solve the problem the same way. So these are the two basic ones that we're going to use. And if you notice, we labeled the point before. That's still part of the construction, really. We labeled where Mac was. So you can label points of intersection with letters. Some other terms, a figure is basically just a shape you draw in 2 dimensions. Equilateral triangle, hopefully, we made that. Hopefully you're familiar with it. All the sides have an equal length. You could also say all sides are congruent. That's fine. One thing you can't say is all sides are equal. When we say equal, that means exactly the same. So if we go back to the drawing we did, you can't say JM and JS are equal because they're in different places on the plane. They would have to be exactly on top of each other to be equal. So you have to be very careful. I know it sounds like a semantics thing, but there really is a big difference between saying equal and equal length. Collinear, co together, linear line, 3 points on the same line. And length of a segment. Usually, you're going to see this notation with just the 2 letters. I mean, you can write it with dist and then put 2 points in there, but that's not as common. And last thing here is our common notations. So when we have array, this one's very important. The order of the letters matters for array. You always have to start with the vertex, where the array is emanating from. And it doesn't matter which way it's pointed. Array AB starts at A and it goes through B. And we always write it with the array going from left to right on top of it. Now with line, it's different because has arrows on both ends, it doesn't matter if you write AB or BA. Those are the same. Same goes for a segment. So here we're just naming things. But now we want to actually say how long the segment is, like I said before. You just write the 2 points. That's a number. So AB could be 5. The other ones are names of things, so these don't have numbers associated with them necessarily. And distance, same as I said before. So in this lesson, we learned how to construct equilateral triangles, and we learned some basic vocabulary. Thanks for watching this video.